A very warm good afternoon to all the delegates and welcome back to the post-lunch session at the Pump Symposia. We have had a very wonderful pre-lunch session where we have listened to multiple experts from across the industry share their views, experiences, technology and case studies. And we have had a wonderful round of question answer sessions. So coming to the post-lunch session of the Pump Symposium, we have two training workshops. And to start with the first one of them, I would now like to invite Praveen Singh, Regional Sales Director at Andritz India, and he's going to talk about the innovative technology for drainage, dewatering, and flood control in an industrial as well as a municipal area. Over to you, Praveen. Praveen, you are on mute. Praveen, I think you are on mute.
Yeah, Praveen is on mute.
Yeah, sorry. So something about me, Mr. Kailas already introduced to me. Actually, I belongs to Andritz Separation and Pump Technology India Private Limited and its pump division. And I look after this India, Bangladesh, and Sri Lankan market as a regional sales director in Andritz Pump Division. So, and next something about my company from where I belongs to, and I'm from Andritz Group, and Andritz is globally leading supplier of plant, equipment, system, and services for pulp and paper, metalworking, and steel industry, hydropower station, pumps, solid liquid separation, and municipal and industrial sectors, as well as animal feed and biomass pelleting. So you can see Andritz is having very diversified experiences and working area from where we have the know-how of each and every industries. Andritz is headquartered in Graz, Austria, and we have over 280 production sites and sales and service companies worldwide. And we did about order intake of 6 billion last year in 2020, and sales was approximately 6.7 billion globally when we talk about the Andritz Group. So we are mainly operating in pulp and paper, hydro, metal and separation area. Pulp and paper, which is one of the biggest division in Andritz, within Andritz, and we have share of about 48% from pulp and paper. Hydro is about 22%. Metal industry, we do about 19% and separation about 11%. So this is something about our group and the business area where we are working. The pump is coming under the hydro business area of Andritz, and where we do also electromechanical equipment for hydropower plants, turbine generators, turbo generators, hydro turbines, and service and rehabilitations. In pulp and paper, we do everything from starting from pulper to finished product. We can do everything, and then flue gas cleaning system, recycling, shredding solutions, different type of equipments we are doing. In metal industry, we do complete stainless steel, carbon steel, non-ferrous metal strip, and industrial furnace plants. In separation, centrifuges, vacuum belt filter presses, this type of equipments. So since we are here for talking about pumps, so how Andritz is helping to its customer for pumping, innovative pumping solution. And for your information, it's all the pumps are IIoT Industry 4.0 enabled. So most of the pumps are equipped with all the sensors which is required for IIoT, and we have cloud, we have softwares to connect them and do all type of monitorings and all. So basically, Andritz, when we talk about Andritz pump division, so we have everything from the one source, like starting from research and development, hydraulic calculation, design, manufacturing, quality management, automation, project management, erection and commissioning, and after sales service. This what this means basically, this means is we don't have to look to any other organization when it's come to the hydraulics, because we are doing the hydraulics since more than 172 years uh, in for industry, and we develop everything from water to wire for pumps or any type of hydraulics like hydro turbines or small pumps or big pumps. uh, all kind of pumps are being manufactured, and from concept till the service. So this is what everything is coming from the single source, and that is our strength basically. So we are operating in many different area like water, pulp and paper. I will not go in much detail in that. Food, mining, power, other industries also. There is no limit, and we have almost all kind of pumps which we are using in either industries or municipal areas. So you can see starting from end suction to vertical pit pump or submersible pumps or self-priming pump, ASP, medium consistency, high pressure, all type of VT pumps, concrete volute, or pump as a turbine which runs in reverse direction. Also, we do RCPs for nuclear power plant, reactor cooling pumps, which goes directly inside the nuclear power plants. That we also call the main coolant pump, which we developed together with the reactor manufacturer for nuclear power plants. So first, something about the research and development which take place in Andritz. Uh, this, uh, we do everything starting from design, manufacturing, and model testing. So these three are the main dimensions of developing the hydraulics in our state-of-art uh, Research and Development Center, which is located in Austria, Graz city, and that is also a National Hydraulic Laboratory of Austria, which do all the hydraulic certification, model testing, uh, mm, uh, certification, and all type of quality testing on behalf of Austrian government. So within the pump division, this hydraulic laboratory that is called ASTRO is we have a different independent organization which do uh, all the testing and certification, and also develop all the hydraulics for pump division of Andritz. So it's not that it's a central organization. We also have this testing center people from all over world. Like we have R&D engineers sitting in India, also in China, also in Brazil, Germany, and of course, headquartered and leadership is coming from Austria. So some of the pictures. So we have 7 type of test field: thermal cycling test field laboratory, VPI plant, chemical laboratories, where we do all the simulation for all the chemical or different type of liquid and materials. We have the bearing test stand also. We have fan and cooler test stand also. We have balancing pits. We have large rotating machine test fields also. So where we do the model testing and different type of hydraulic testing in our laboratories. So this all product which are coming are a result of this research and development and laboratories which is located all over the world. So we have different type. We have all laboratories at Andritz have their own team, and most importantly, we have our own software and hardware. We do work on our own design software and on hardware for all type of CFDs or model designing or installation and adaptation of model component in the workshop, preparation, execution of documentation for model testings, supporting measuring techniques and software. So everything is developed in-house. So that is our backbone of our all the hydraulics. And most importantly, I will tell you here that the uncertainties of this test are sometimes 0.000. So it goes in three level after the decimal. So that type of testing uncertainties we are having in our test. Okay, so today I'm going to talk about pump operation. We talked since morning a lot about the pump priming. And when it's come to the operation, the suction condition, when we have to deal with the negative suctions, and since morning we are hearing about this a lot of problems. It's coming when we have to deal with the negative suction, when we have to deal with the fibrous liquid like sewage or sludge or fibers, stock, pulps, effluent, industrial effluent. So we are facing a lot of problem even for the clear water application or raw water application. So why priming is required? Because pump is a centrifugal machine, we all know, and which cannot work or which cannot pump if liquid is not available at the center of pump impeller. Means pump cannot suck water. Many people having this misinformation that pump sucks the water, but no, pump doesn't suck water. It can only pump liquid, any of the centrifugal pump, if the liquid is available at the pump center line or impeller eye. So then it can do the pumping. It cannot suck water. And even if we remember, if we recall when we are installing the small Tullu pump, or we say the self-priming pump in our household to get the water from the municipal lines for the drinking purpose, that pump also need priming. If you remember, the manufacturer always suggests to open a small nipple and pour some water in that volute. So that is the different method of doing the priming, but that also need priming. That small pumps also, which we sometimes understand it sucks the water, but no, that also is not sucking the water. We are doing the priming, filling the water in that volute so that it can do pumping. So the pump required priming if lift is too high, of course. Then we need pumping if liquid is far away from the pump is far away from the liquid, or it's need priming if there is leak in suction line. It's required priming if there is no air vent on the pump. For good priming of a centrifugal pump, consider the pipe size and pump geometry very carefully, and have a watch, of course, because we are doing priming. We are not reducing the NPSH. Of course, there will be the requirement of calculation of NPSH-A and NPSH-R, which is needed by the pump. So there is no concession on considering the NPSH available when we have to do any kind of pumping by the centrifugal pumps. So we have seen in industry when we have to deal, always the pumps are not in touch with the liquid. So in that case, we have to do priming. So for priming, we have to do adopt different type of priming method. Like sometimes we install football. Sometimes we and football, basically it's stop the water going away from the pipeline, and it's maintain that the connectivity within the liquid and the pump, and then the pumping is happening. Another method is if we have air vent. By that we can have we can suck all the air and we can bring the liquid near to the pump and we can do pumping. So that is another method. And suction piping design and proper priming is very important for a pump. So bad pipe design also may sometimes cause pump for the serious cavitation. So cavitation is another subject which I'm not going to touch today, but of course the priming is very important for any of the centrifugal pump. Okay. So another method for centrifugal pump, like in industry, which is this is very I will say common or very popular in industry, to build a priming tank and bring the liquid near to the pump so that it can do pumping. So we have to design modify the suction line, and we have to build a tank there to do the pumping. But of course, this dimension and everything of this priming tank need to be calculated by the pump specialist. Okay. So what are the options available if we have we don't have positive suction always, and we have to deal with the negative suction? So of course, the option 1 is submersible pump. We have option 2, sump pump, or we have option 3, that is also very popular, that is vertical turbine pump. But what we have to consider when we have to go for all this 3 option, which is on the top. With submersible pump, we have to deal with very expensive motors. Same for other 2 vertical pumps, where we have to go for the vertical motors. That also is a little bit expensive than horizontal motors. And most importantly, we have to deal with the situation where we cannot see what is happening inside the pump. Like horizontal pump, you can see what is happening in your pump, where is the vibration, how the pumps is running, and maintenance is also very easy for all the horizontal pumps. I'm not criticizing here all the 3 pumps, because we also do all these 3 pumps, and we do have this product also in our product portfolio. But sometimes depends on the situation, we have to choose from the options. So submersible pump, sump pump, VT pump maintenance and operation is also, as I said, during operation you cannot see what is happening with your pump. The physical monitoring of the pumps are very difficult. When you have to maintain these pumps, you have to take out, and that is also a very, I will say, sometimes it's a very dirty work sometimes, because you have to deal with the pump which is having a lot of I will say seaways, which is submerged. So of course we have to do it professionally, but yeah, problem is there. So, and the number of component, if we have to go for just accept this submersible pump, the sump pump and VT pumps sometimes is having multiple shaft sleeve, multiple couplings, then a lot of fasteners, then long pipe, everything. So the lot of component. So we have to deal with that. We have to keep that in inventory. So what is the next solution? So for that, I'm today concentrating my discussion on the 4th option, that is called vacuum impeller pump. So vacuum impeller pump, I will just go a little bit more deeper with this option. Of course, this also have some pro and cons, but of course, this is also a innovative solution for industry, or for municipal corporations, or flood situation, or anywhere, or raw water intake, any kind of application. So this option is also available from the Andritz now. And what is behind this vacuum pump impeller? What is in this? So let's go more in detail. So This we also call self-priming feature. So because it have integrated vacuum pump, vacuum impeller. So no need to have separate vacuum pump for the priming. And so just little overview about this pump of self-priming type. So we have all kind of pressure grade like PN10, PN16, and PN25. We can go head up to 160 meter and Q up to 9,000 meter cube per hour. Efficiency, we have already gone up to 90%, but depends on the duty condition and hydraulics. Yeah. So field of application, these pumps can be used in the media, water supply, wastewater, sewage and its treatment, food industry, pulp and paper industry, sugar industry, and application fact already told you. Here is some typographical error, but it can go up to now 9,000 cubic meter per hour. So and this is coming from the Andritz ACP family. So ACP family is basically, ACP is Andritz centrifugal pump. ACP is Andritz centrifugal pump, and ACP is our one of champion, I will say, in process design. Even in India, we have about 3,000 pump installed from this series. And worldwide, if we go, more than 30,000 pumps are working at different customers, this ACP series. And this is one of the latest hydraulic, I will say, in process industry from any of the pump manufacturers, because this has recently developed, and still some development is still going on for this series. And many type of hydraulics and many type of features are being added every day. So this is from the ACP series. And we have efficiency, I already said, can go up to 91%, and many type of different sealing options we are having available. It have modular system for bearing support sizes. So more than 60 pumps, 60 pump types, and with the 8 bearing support. So means only 8 bearing support, 8 shaft sizes are there in all this 60 type, and maybe the pump model can be approximately 160 with these 60 pumps, because we have different pump models for closed impeller, different for semi-open, different for fully open. The performance curve is also different for all the pumps. So that's why we have all different pump models. So a steady shaft ensure minimum shaft deflection and low mechanical vibration. And this pump also have the feature like we have a spline shaft with that have the male and female arrangement with the shaft and impeller. So a spline gear shaft arrangement is there for this self-priming pumps. Different type of impellers, of course, to choose with. If we have to deal with the sludge or effluent or sewage, we have different impeller. Then if we have slightly contaminated water, we can go for semi-open impeller. And in that also, we have different number of vents to deal with. And like 3 vent impeller, we have 4 vent impeller, we have in semi-open, we have 4, 5, 6, and up to 8 vent impeller we are having in this series. So that basically depends on application, which application we have to deal with, and we can choose any type of impellers which can fit to the application. So the next is about the construction, how this pump looks like. So if you see here, we have internal vacuum pump. So what we have done here is that we have a one main impeller. I will show you the exploded view of this pump, but we have internal vacuum pump on this common shaft. So we don't need to consider additional vacuum pump impeller to have the priming. So that is the basic principle of this pump, and that save a lot of time and a lot of space. because when you have to do priming and you have to install a different external vacuum pump, that create a lot of hurdle during the installations. So then we have air degassing pipe. So why this air degassing pipe is because whatever gases we are getting from the suction line, that has to be degassed. Another thing is when you have to deal with the fibrous liquid. Fibrous liquid which also include all type of sewage or sludge or effluent or slurry, because when there is contamination in the water, that doesn't come alone, that comes with the air inside. Even for the pulp or stock in the paper industry, so there is it's a basically a very puffy material, so it have a lot of gases also inside. So sometimes people wonder why there is cavitation in sewage or sludge application, and always the impeller is having problem, and there is a lot of corrosion and pitting corrosion, other type of corrosions also. So the answer is its content air, and if you will not degas that air, that is going to hit your impeller and hydraulic parts, of course, also the volute gassing. So we need to do degassing also, so that we can maintain the air pressure within the volute casing and hydraulic part, and we can get a smooth pumping. Then we have vacuum relief valve, so that while pumping there should not be any trouble, and all the gases which are coming, that can go out easily. We have a pressure gauge to monitor the, because we have to set the pressure. That is a little tricky, but it depends on, we have to basically make balance to do the priming between internal and external pressure. So we have to adjust this through the pressure gauge, and we have to adjust the vacuum relief valve pressure also. So that is important to have a pressure gauge on that. And then we have a separator. The separator, this means this separate the two chamber, one chamber which is doing pumping, where the main impeller is installed, and then the another chamber is
Raveen, I think we have a small issue.
We have vacuum pump where all
I think there is a
degassing or priming activity is
Raveen,
happening. So we have to separate these two chamber. Otherwise, what will happen? The main the liquid will come to
Praveen, your voice is breaking. Praveen, your voice is breaking for us.
The priming, and it will be the complete philosophy. So, and this separator is patented parts, this pump, and we have got the patent also for this separator. So this is very unique, and this work as a primary mechanical. So this basically seal the volute casing, or and this is also called sometimes dynamic sealing. So
Raveen, can you hear me? I think there is a lot of breakup at your end.
Based on this separator with the dynamic sealing, all for slurry or sometimes also for pulp or stock or very abrasive liquid pumping. So that is called dynamic sealing. Means there is no mechanical seal like what we have always like carbon versus ceramic, balanced, unbalanced, and single, multi-load spring. So the different type of mechanical seal which we are using in so that all is can be avoided, and we can do the dynamic sealing. That is basically the components. Okay, so here is the exploded view. Of this pump. So if you can see, the main pumping is happening. The pumping is happening in this main volute casing, and to seal to close this chamber, and then we have a separator that is we already talked about. And it's a pump back whatever the small amount of liquid is coming back, coming to this chamber, and then it's do the sealing. Then we have vacuum front cover, and then we have a small liquid ring vacuum pump impeller on this same.
Praveen, we seem to have a audio issue at your end.
Casing. So for that, it's give the lubrication also. So that water, whatever
Praveen,
is
can you hear us?
Yeah. Yes, Mr. Kailas.
Your audio is breaking, sir. Your audio is breaking continuously for us.
Okay. Okay. Okay.
The internet seems to be slightly unstable at your end. So your voice was breaking for the last 7-8 minutes. Many of
I
us
see.
could not
So,
completely hear what you were saying.
okay, then maybe I will close my video. Then I think it should be improved, right?
You will have to reshare your PowerPoint presentation. Right now you're sharing has also got discontinued.
Okay, sorry. Now it's fine.
Sir, Praveen, can you go back one more slide and start all over again?
Okay.
Yeah.
So we were talking here about the internal vacuum pump, which this pump is having. By that, we are doing all the priming, and after that, we have a degassing pipe, because whatever the liquid is coming, whatever the air is coming to this pump, that has to be degassed. So it have a different application basically. That is nothing has to do with the priming, but this is a additional feature when we have air content more inside the liquid. So basically, when we are dealing with the fibrous liquid like seaways or sludge or effluent or stock or pulp in paper industry, or also the slurry application. So the whenever fiber is coming to the liquid, so that don't come alone, that come with the air inside. And sometimes people wonder, why the fibrous liquid pumps are having more cavitation problem. So cavitation can be avoided with this air degassing system. So it can degas all the air which is increased in the liquid, and then pumping can happen smoothly. So then we have a vacuum relief valve which release all the airs. Then we have a pressure gauge in this because we have to adjust this vacuum relief valve pressure, and so that it can do proper priming. So for that we have a pressure gauge in this pump, and we also have a separator. So separator, which I was talking before also, that it's a patented design of Andritz. We got patent for this very unique separator. And this separator we also call sometimes dynamic sealing. So when we are doing sealing, we are using multiple type of single mechanical seal, double mechanical seal, or cartridge seal, or split seal. Different type of sealing system we are using, but this is a completely different component sealing, which we also say separator in our industry. So this have the role to separate all the pumping liquid, whatever is being pumped through the main chamber, uh, from the vacuum pump impeller. So it's a separate all the liquid, and it's do the sealing. It's provide the sealing from the pumping media. Okay, so this is the exploded view of this pump. You can see there is a main volute casing where we have the main impeller of this pump, where the pumping is happening. Thereafter, we have a specific casing cover. Then we have a separator or dynamic sealing, which provide the sealing from the main pumping liquid. And then we have a vacuum front cover, then vacuum impeller, very small size on the common shaft of this self-priming pump, and then the vacuum pump casing, which seal all this chamber of where this air is being released. And then we have a single mechanical seal in this. So what I was talking about, that we need to have the sealing water, because this is a liquid ring vacuum impeller we are having on this pump on the common shaft. So to create the vacuum, we need lubrication for this impeller, and then also we need to lubricate this mechanical seal which is installed at vacuum pump casing. Uh, so basically this sucks all the air, and then it's do priming, and then pumping is happening. This is how the simple is. Uh, Another thing which I was already talking about, that whatever the water, service water or lubrication water or sealing water, only one connection you have to give to this pump. So whatever water connection or service water connection you are giving, that water will not go to drain. You don't have to waste that water. You can recollect and reuse or recirculate that same water within this pump. We have developed some system for that, which can recirculate within or it's basically coming from the seal manufacturer, only a small equipment which recirculate this water within this and lubricate this mechanical seal, and as well as this vacuum impeller also. So this is the basic uh, information about this pump. So with this, we have already tested with this pump the liquid like viscous media, that is sugar concentration up to 70%, high solid content media, that is sewage, pulp, paper, or other applications also, clear water, raw water, storm water. We have also tested with wastewater, sludge, and effluent. So advantage is easy operation and maintenance of this pump, because you don't have to go to install the pump deep inside the sump, and this will provide the easy maintenance operation. Self priming save space and investment cost also, because you don't have to invest for expensive submersible or vertical motors. Allow for more suction height, it can go up to 6 meters, but of course we have to calculate NPSH. Don't forget to do that. And we have non-clogging impeller also, because as I already saw, that we have semi-open, we have fully open impeller, and with the different number of vents, so that we can choose the impeller, which impeller to go with which application. Okay, and this is how to start this pump. So first, basically, we have to open the sealing water connection, and then we have to start our motor, then open the delivery valve, and when we have to adjust the vacuum adjustment valve so that we can have the proper pressure and we can do the priming. So this is a very simple startup method for this pump. The single line diagram. And okay, let's move to next. So share some experiences and reference for this pump which is running in India. Because when we talk any of application, people always talk about Indian condition. That is very important, you know. So these pumps are of course running with the Indian condition. So this we supplied to UP Jal Nigam and for Teneri effluent pumping in Kanpur. And you should know that these pumps we supplied when there was last Kumbh in Prayagraj in 2019, beginning of 2019. These all pumps were tested in our test loop in Chennai, in India, and with the all torque transducers and closed loop system. So everything we have in place in Chennai, and we tested all these pumps in our workshop, and you can see how these pumps are running. There was some problem, you know, at some of the pumps. Why there was problem? Because we know we have to deal here with the centrifugal pump, and we supplied centrifugal pump for this application. But unfortunately, there was something more to handle. So when we open the pump, you can see the pictures which our service engineer found while opening this suction pipe, what kind of material it was handling. But once it was clear, because this sump was closed for operation when we were doing this installation of new pump. I will not disclose, but this was a replacement of some of old installation of some of the pump manufacturers from India, and which was failing every week, I will say here. So when we saw this type of material which was stuck, the reason was the sump was not clear for many months, and a lot of material was in the suction side, and the vacuum impeller is so heavy that sucks everything whatever was coming to its contact. So when we open and when we clean this pump, and after this we added some knife on the pump section, so that if any long fibers are coming, then it can cut. So we welded some knife, very specially designed knife. You can see the video of that Swiss knife on YouTube also, from Andritz pump channel, and that we called Swiss knife. So we welded that knife on the suction, and thereafter there's no problem in that pump. But you can imagine what this pump was handling. So this problem we faced after 1 week of installation, and immediately once we clear, everything was smooth. So it was dealing with the hairs, fat, and a lot of other animal waste, and everything which was coming to the pump. So this type of application also this pump can handle. So you can see some of the pictures from our test loop in Chennai, where we tested this pump, and with the presence of UP Jal Nigam chief engineer. And we have a very sophisticated, very advanced test loop in Chennai, where we can do the testing with one single person sitting at the computer. He can operate the whole test loop. No, there is no human interface. All the data can be collected automatically, and we have a data acquisition system which comes and generate automatic performance curve. So there is no human interface, no error possibility, and most importantly, I would like to share here, this is the test loop where we are where we have no interface even from the motor on the pump testing. What is different in the testing pump with the motor and without interface of motor is normally how we do the test is we get the type test result of motor from the motor manufacturer, sometimes new, sometimes 5-year-old, and that type test result um, power factor and efficiency we take from the motor manufacturer type test result, and then we derive the pump efficiency by current measurement. What is different here is we directly go to the root. We have torque transducer in our system, and we directly measure the torque and we arrive the pump efficiency. So with motor current test, you are deriving the pump efficiency, and here you are arriving the pump efficiency. So 2 pi nt, the basics, so we can directly measure torque, multiply by rpm, then divide by 9550, you will get the power. So these pumps were tested with that kind of system, and I am very happy to say these pumps are still running at full satisfaction. There is no problem once we open the pump after 1 week of operation, because there was a lot of thick material inside the pumps. The same type of this pump is also running for stock and also for causticizing plant in Century Paper Mill, and we have about 6 pumps together with 200 other pumps which are running since 2009, and still it's working and working very satisfactory. We have such pumps installed in ITC paper and board mill in Bhadrachalam for pulp and also for mill effluent drainage pump. So 4 numbers we supplied in 2012 and still running. We have same kind of pumps installed in Hindustan Zinc, Dewari mines, Udaipur, where we have supplied these pumps for effluent drainage. 2 pumps only, but running since 2018, no problem. Then we have some other references in India. We only don't do this small pumps, but we also do very big sizes of pumps. Like we supplied Bhima Stage 1 in Andhra Pradesh for irrigation projects in 2008, and where we have 4 megawatt of 3 pumps running since 2008. All well. Bhima Stage 2, 12 megawatt pump, 3 numbers running well. Then Karnataka Niravari Nigam Limited, these pumps we supplied in Thotapalli lift irrigation scheme, 15 megawatt, 3 pumps in 2013, all well. We supplied also for Kalwakurthi about 20 cumac and 50 meter, 12.5 megawatt, 10 pumps in 2011, all working well. Then something about the Bahubali pump. So, there was a big advertisement 2 years ago in all the newspapers when about 7 state ministers, chief minister gathered to inaugurate these pumps, which was called Bahubali pumps in Andhra Pradesh. So that is for Kaleshwaram lift irrigation scheme. So Kaleshwaram, most of the big pumps belongs to Andritz. Kaleshwaram stage 1 and stage 2. 19 pumps of 60 and 83 cumac, and motor power is 40 and 40 megawatt for both the pumping stations. Efficiency up to 91.5%. Impeller dia was 3.5 meter, and weight of pump was 200 ton. A diameter was 5.5 meter. So these pumps are also already commissioned and running. Then Kaleshwaram 12 and 14, we have supplied 31 cumac and 35 cumac head up to 107 and 66 meter, 40 and 34 megawatt pumps. So such experience is there with Andritz with this innovative solution of self-priming pump for your application. And here is our contact. Any question? I'm open for that.
Praveen, thanks for the presentation. We do have a few questions which I will take up now. Mr. Singh is asking this question, Praveen, that you mentioned in your slide that there is a 90% efficiency. Uh, so he is asking what is the minimum percentage of efficiency against what you are claiming of 90%?
Uh, the up to 90% efficiency is basically with that series of pump we have achieved efficiency up to 90%. Maybe for particular pump model, so there is no benchmarking, but of course there is benchmarking from all over most of the pump manufacturer, I will say, in when we develop the hydraulics. So you will found the efficiency where we have like 90%, or it cannot be 90% efficiency for all the pumps for sure. As I already told when I was presenting that slide, it cannot be always possible to have 90% efficiency. But yes, we have 90% efficiency for few of the pump model or few of the hydraulics. So that is possible. But uh, we are the company, we the know-how of the hydraulics are coming from the hydro fields. The profiles and know-how of the hydraulics is coming from there. So, and that is the field where zero point zero 0.01 or zero point zero 0.02 efficiency also matters, because we have to deal in the megawatt, and even zero point zero 0.01 or zero point 0.02 efficiency also make a lot of difference. So the efficiency which we say we also achieve at site, and we develop the hydraulics with, I will say, with the after the benchmarking from our competitors, and also from the market. We develop the hydraulic in such a way that it should outperform whatever available in the market.
Praveen, we have a question from Shivaji Ghadge. He says, can we use this for raw sewage transfer? Praveen, can you hear me?
With
Praveen?
some limitation, because
Praveen, I think we
with
missed
some
out your
limitation.
voice in
Of
between.
course, we can use this for raw sewage also, but we have limitation on um, the solid handling size. The solid handling size will be lower as compared to single van or two van impeller, because single van impeller, which is especially designed for sewage, or two van impeller, that have very wide solid handling size. So we are working on that also. Most probably we hopeful that by end of 2022 we will have a solution for big solid handling capacity also with this pump. We are working on that hydraulics, but up to now we have only fully open impeller, and with fully open impeller we have limitation. It depends again on the pump size, but normally I will say we have some limitation that can be checked separately with us. If the solid size is small, of course we can.
So Santosh Patil is asking this question, for ACP self-priming pump for priming work function, is there any additional external water required for initial stage, or has any inbuilt provision been made? Praveen?
Yes, this is what we were talking about. We need some lubrication for vacuum impeller, and also lubrication for So we need water approximately, it depends on bearing support size, but it starts from 3 liter per minute and it goes up to 8 liter per minute. Depends on the bearing support size, but you will not lose your water. You can reuse, you can recirculate your water, but water requirement will be there for self priming.
Okay. One final question that we will take. When you were speaking about your Bahubali pump, I think one of the questions came was that can you tell us the operating parameters of these pumps?
It was already mentioned
Praveen,
there, but I will tell you again. The Kaleshwaram lift irrigation scheme capacity was. Can you hear me?
yes, it's coming and going, but right now we can
Hello.
hear you.
Can you hear me?
We can hear you now.
Um, okay. Okay. So Kaleshwaram pump capacity was 60 cubic for Kaleshwaram stage 1, and for stage 2 it was 83 cubic. So this was the capacity.
Okay. We have a question from Abhijit saying that pump efficiencies have a relationship with a specific speed. Do such high efficiencies claimed by you adhere to those limits or do they exceed those? Praveen, can you
Of
hear us?
course, basic cannot be avoided. Basics are basics. So, but in when we do the CFT, there is to Chaudhary Saab. When we do CFT, sometimes we found the efficiency zone, even which is like we have a curve in HIS, which we call as a maximum attainable efficiency, but that also with uh, also have some disclaimer, you know. So when we do the CFT, when you run through the designing and the predictive modeling, then sometimes you get something better than what we have in the standards. And really, since we are a hydraulic company and we are doing hydraulic since the last 172 years, so we have few of the hydraulics which are really good and very good efficiencies. But basics, of course, we have to follow.
So thanks, Praveen, for taking time out of your schedule and sharing this wonderful presentation and knowledge with us. In case we have any more questions, I will share them with you over email, and I request you to answer them once your time permits.
Sure. Thank you very much. Thanks for giving the opportunity, and thanks to
Thank-
all for listening to me.
Thanks, Praveen.